Hello sir, this is Team Bucatini's video demo of VOR project. My name is Kalyani Singh and I'm the co-member of Preetam Dhanoa. So I'll be quickly running through all the Java classes that we have made. The very first one being radio.java, the next one is the VOR class, the third one is interface class, and the fourth one is the driver function from where we are driving the whole project. And we have also included a test package which contains radio test and VOR test classes. These classes are particularly linked to radio class and VOR class respectively. They contain specific test cases which are linked to all the functions which are there in the actual classes. Like if the radio class has 3 functions, we have created 3 test cases in radio test class. These test cases have been created in Java using JUnit. So the very first class is radio.java. Radio.java class contains a radial function which is generating the radial randomly. The next function is frequency function. Frequency function is getting the input from the user. We are using the frequency function to get the Morse code, to show the Morse code value of that station, VOR station. In get Morse code function, we are simply mapping the frequency values to their respective Morse codes, and we'll be showing the same on the VOR instrument. The third function is signal quality function. So we are randomly generating the radial plus the signal quality. Signal quality is being generated on the basis of 1, 6 and 8 values. So whenever the value is 1 or 6 or 8, the signal quality will be good or bad accordingly. So for the signal quality, we have made sure that the signal quality is bad when the plane is over the VOR station and when it is on 90-degree angle to the VOR station. The next class is VOR class. VOR class is getting the input value of radial from radio class, and then the VOR class is getting OBS value as an input from the user. The CDI value is simply the arc value which has been normalized, and then in the CDI function we are also getting the deflection using clamp function. So the arc function, basically it is normalizing the value by subtracting them first and then using that value to generate a value which is anywhere between 0 to 360 degrees. We have used polymorphism here. We have included the normalize angle function for 2 different variables and 1 variable. So this value, normalized value of arc, is used in clamp function to get the deflection. -10 and 10, these are the boundary values for our VOR scale. So the clamp function here, it is getting the maximum from arc and -10 and 10 values. So this is how we are calculating the deflection. Signal good and bad quality, as I told you before, it is depending on whether the plane is over the VOR station or it is at 90 degrees to the VOR station. Next function is for going to or from. This we have generated based on the arc function. If the value of normalized arc is greater than 90, then we are in the to area or in the from, otherwise in the from area. And the over the station function is the calculation for if the plane is over the VOR station or not. This function is generating the value randomly. For the interface class, we are using JFrame, which is containing various text boxes, labels, and buttons. In the interface class constructor, we are giving the basic functionality to the interface. So here we are using 4 different buttons, left, right, stop, and start, and we are giving the basic functionality to all these buttons. The initial function, it gets the frequency and OBS value from the user, and those values are given in the text boxes by the user. Left function is decreasing the OBS value by 1. Right function is increasing the OBS value by 1. Clear function is clearing all the text boxes, and the update function is updating all the text boxes. Like the Morse code value that is updated from the frequency value, and OBS value is updated from get OBS function. The needle value is updated from get CDI function, and we are getting the direction value from is going to function. We are getting a signal good or bad value in the quality function. We'll be displaying all these values on a VOR. This code basically gives a structure to the VOR instrument. So the last is the global class, which is reinitializing all the variables that we have used in the interface class. And there was something interesting that happened while we were making the project. We are passing the radial value, which is being generated in radio class, to VOR class, and the same value in interface class. So when we were getting the value of radial from radio class, on needle deflection, the value was changing. For a single OBS value, the radial was showing different values. This was a conflict. So we decided to make a global class which reinitializes all the values. For testing purpose, we have radio test and VOR test classes. I'll be showing how one of the test case functions is working. For test normalize int function, which is taking two values as parameters, we are giving a random value to those parameters, and we are calculating expected result. We are also getting actual result from VOR class by calling the respective function to which this test case belongs. And finally, we are asserting the expected value with the actual value and checking if both the values are equal. This is how we are performing almost all of the test cases. I'll be starting with the functioning now. This is the VOR instrument. I'll give a random value of frequency, say 116.9. The random OBS value, say 257, and start simulation. ID gives the Morse code value mapped to this frequency. Radial is generated randomly. To and from is giving from for 257 value, and good and bad is the signal quality. OBS plus increases the OBS value by 1. OBS minus decreases the OBS value by 1. So when I'm going close to 245, there we have the deflection. The needle is in center when we are at 245. There goes the other side. So the signal quality is changing randomly, good or bad. Stop clears all the fields and we can start all over again. This sums up the functioning of the VOR project. We have tried to commit the code frequently and keep a track of subversion control. As of now, we are on version 0.1.7. We are open to your suggestions, comments, and questions. Thank you for watching the video and giving your time to it.